Hello children, hello everyone. In last few videos we understood the tricks to solve NLM problems and some of the problems we already discussed. I think 15. So 14 questions we already discussed based on NLM, the Newton laws of motion. If you have any doubts on how to solve tricks, formulas, everything, go back and give part 1, 2, 3 so that you get clear with the NLM problem. Now in this class we're going to study the passage type question, how they will going to discuss and how going to ask. My question might be coming like this based on this passage. Let us see the based on outward mission. This problem is given 30 kg block and 70 kg block. When they're released and they freely they can suspend. Okay, when they're released, what will happen, children? Because it is more mass, 70 kg is more mass, right? So that the body, the string will come down. Okay, this will come down and the same time this will go up because they connected with the same rope. Either that the rope is in the same time it is inextensible. Okay, because of this inextensible, what will happen? The rope will move upward. This is a go upward and this will come up downward. So acceleration will be in this side it will upward direction and this side will come downward direction. This is what direction of acceleration. Now, in case of pulley problems, I'll just see you the formula. See, acceleration is given by m2 minus m1. See, not need of taking always m2 minus m1, which will have a more mass you have to take first and a less mass you have to take minus. So only this just a difference of two masses by sum of the masses. Difference of the mass are into sum of the masses into gravity. Okay, children, this is the formula for acceleration. Similarly, the formula for the tension in the cord. Okay, the tension in the cord, that means here the tension what is acting in the cord, we can find like this. Tension is equals to 2m1 m2, the product of the mass divided by sum of the masses into g. This is the formula for tension. Clear, children? And vertical distance of one. Okay, thus I'll explain later. Just two questions we see easily solve, right? So m1, what is the m1, children? Let us say this is m2 m1. Okay, m2 is how much, children? M1 is 30 kgs. Okay, m2 we have to take first, right? Just a second. 70 minus 30 we are going to take, children. Okay, m2 is 70 kgs minus of 30 kg divided by 70 plus 30 into j is 10. So simplify this, children. 70 minus 30, what you will get? You will get as 40, right? 70 minus 30, 40 divided by 70 plus 30, it is 100 into 10. So now you can cancel 1 0 and 0. Again this 0 with this 0, what you left? Only 4. So that what you will get, acceleration is 4 meter per second square. That's it. Understood, children? Acceleration is 4 meters per second. So option for 15th one, option B. This is the correct answer. Next, tension in the cord. We need to find the tension. Tension formula is this. So 2 into m1 is given as m1 30 kgs and m2 is 70 kgs divided by m1 is 70 plus 30. It is 100 into gravity is 10. Understood, children? So cancel 1 0 here and cancel 1 more 0 here. So now multiply. 7 3s are, so 3s are 21, 21 2s are, what will come, children? So multiply this. 7 2s are 14, 14 into 3. So 14 into 30. Let us think. 14 into 30, 14 3s are, how much you will get, children? Multiply. So that will be the answer for this question. Okay. So it will comes around 420. Okay, just you multiply and check, children, it will come. So answer will be for the 16th question, it is option D. Okay, next question. 17th. Okay, 17th question, I'll just take it to place. See, first you read the question. A vertical distance between the two masses is 1 meter. The time at which distance becomes 0 is what time the distance becomes 0? They're asking. Yeah. I'll just write in the empty place. See, children, what they're giving here, the distance between the two cards is 1 meter. So let us take this is the top and this is the down. So the distance between them initially, how much, children? It is 1 meter is there. Okay, like this 1 meter. They are at a distance, vertical distance of 1 meter. Now, at what time they becomes distance becomes 0. That means at what time they both will align in the same position, like this and like this. What time they will come back in the same position. Initially they are at some distance of 1 meter difference from this block to this block. 1 meter difference is there. At what time both will come at the same height, so that what the distance becomes 0. Okay, so imagine how much this block will move. Same time this block, that much, suppose it will move 1/2 meter down. The same time it will also move 1/2 meter down. So what will happen, children? This is moved 1/2 meter, this will move 1/2 meter. So total distance how much? Half plus half. Total is 1 meter, right? So 1 meter of a distance is shared by 2. This will also come 1/2 meter down. This will also go 1/2 meter up. So that means actual distance from the 0 point to this body is half. From 0, how much this distance moved? Initially it is 1/2 meter above. It will come 1/2 meter down. And the same body, this is 1/2 meter down. It will come 1/2 meter up. Understood? This we can take 1/2 meter, and this is also moved 1/2 meter. So distance moved is this. Finally, when they reach the their initial velocity, when they're starting to reach initial velocity is 0, we can understand. Okay, so you know the formula that S is equals to ut plus half at square. So equations of motion we can observe, understand to find acceleration. So equations of motion, this is initial velocity is 0. So that matlab what will happen, children? So entire term will go into 0. Now, yes, what is the distance given here? The 1 meter. Okay, distance is 1 meter is equals to half into acceleration. You need to find out into what is the time. Okay, acceleration we already found, no? So what we got in the first problem, acceleration is 4. So we can apply this acceleration. Okay, just a second. Because acceleration we already got from the last problem. So instead of A, we can write acceleration in. Then make life easy. So put acceleration 4. Okay, so 2 ones are 2 twos are. So 1 is equals to 2 t square will come, r t square is equal to, send this one down in the numerator. So it becomes 1 by 2. Understood? R t square is equals to 1 by root, will send this side, no? So this root I am sending down, so it becomes a root 2. Okay, children. So t is equals to 1 by root 2 seconds will be the answer. Okay. So here is the answer, right? But this is wrong answer. 1 second, children. Somewhere we did a mistake. Yeah. See, I am not taken here half distance. So because how much distance traveled is only half, not 1 meter. So distance traveled I need to take as a half meter. So from there my steps will going to change. Sorry, children. Correct this. Yeah. Yeah, finally here you will take, see, half is equals to 2 t square, right? So that you send this 2 down, 1 by 2 into 2 is equals to t square, or 1 by 2 into 2 is 4. So 1 by 4 is equals to t square, or t is equals to 1 by root of 4 will come. So 1 by root 4 means what, children? 1 by 2. So 1 by 2 means what? T is equals to 1 by 2 means 0.5 seconds. 1 by 2 means what, children? 0.5 seconds. So this is the correct answer. Okay, children, option A. Here, distance not we're going to take 1 meter. Here, how much it is traveled distance? Only half meter. So this is what you are going to take. S is equals to half meter. Understood, ma? So this is regarding the passage. So first question, acceleration we can find using formula. Tension we can going to find using the formula. Again, this is we're going to find first. Sorry, this is first we find acceleration. Then you're going to find the distance. Okay, I hope this is clear, children. We'll go to second passage. Yes, observe the second passage. It is direct formula type. M1 and the smooth table attached to it passes over a pulley carries a mass of M2. Like this, M1 and M2 is given. Any condition given? Okay, no condition. So acceleration of the system they're asking. What is the acceleration in the system? Direct formula is m2g divided by m1 plus m2. Okay, this is the formula. So if you want to find, here tension is same and here also tension will be same. So why this block is moving? Only because of the tension. So tension is m1 of A. With what acceleration is moving? Same acceleration will come down also. So for this block we can write free body diagram. M2 of G is acting downwards, tension is acting upwards. That time boss is coming down. So net force here is M2 of G minus of tension is equals to M2 of A. Understood, children? So this is equation 2. Let us take, and this is equation 1. So now substitute equation 1 in place of this. M2 of G minus of M1 of A is equals to M2 of A, or simplified for M2 of G is equals to M1 plus M2. This will come this side, details plus. So what we can write? M1 plus M2. A is same in both the terms. Take it out common. So A is equals to M2G divided by M1 plus M2. Understood, children? This is how we can get the acceleration relation. First for question option A. Second, what we need to find this tension. So in place of tension, acceleration, just substitute value of A. What we got? A value is M2 of G divided by M1 plus M2. That's all. So you will get now acceleration M2G by M1 plus M2. So this is the option A again. Right, children? Next, thrust in the pulley. In the pulley, how much the thrust will act? See, the force from this, both forces are perpendicular to each other. So we can take the force will be like this direction. The thrust or force acting in this direction. So this direction, just imagine like a triangle, children. It will be like this. Vectorial coming like this. We can imagine this is same here, and side is same. So this side is tension. Here also T. Here also T. So we can take here 1 square plus 1 square. Let us take T is common and taken out. 1 square plus 1 square, I'll get root of 2. So tension is nothing but, children, here root 2T. So thrust, what we can know, thrust or the force is equals to root 2 of T. So T value you know here, no, that we can write root 2 into M1 M2G divided by M1 plus M2. Understood, children? So this is option C we can choose. Okay. Like this, we're going to simplify the formula, or else we can remember the tricks how to solve. So you can easily write the answers for this passage. Okay. Yeah. Last from this Newton laws of motion, the this free body diagram last concept. Again, Newton laws contact forces we're going to discuss next class. In the arrangement shown in the figure, A, B, C are connected to the block in the same mass M. Okay, two blocks are there, children. You can see here mass M and mass M. Two blocks are connected in between the three roofs. One roof from the top to first block, and first block to second block is B, and the third block connected, it is free end. Now, string C is pulled with the sudden jerk. Okay, it is pulled with suddenly going to give jerk to this. Okay, 20. Okay, suddenly if you give the jerk, what will happen? Only the string C will going to break. Okay, just we giving jerk to this. So just shaking, what will happen? That only the string C will going to break, because we are applying only force to C. Now, the string B is pulled with a sudden jerk. Only the string B. The string B is no, that string we going to suddenly shake the string. So what will happen, children? That time you can say no, the string B will break. Okay, the body along with this and the string will break. Entire system is called on. Up to here, it will break when you jerk with the B. And if the string is pulled suddenly, okay, string C, this we going to, instead of jerk, just we going to pull it downwards. Okay, when we going to pull that downwards, so what will happen? The A will going to break up. From here, it will going to break, because we are applying force directly downward direction, no? So that here it will going to break. Okay, last one. The string A is pulled with sudden jerk. The string A here, the string A will going to jerk. What will happen, children? Again, if you jerk with sudden jerk, so again the string A will going to break here. Okay, one thing you observe here, if you provide a jerk, okay, sudden change, only that part will going to break. If you pulled it down, entire body, what is connected to this entire system going to change. Okay, that you can keep in brain, so you can easily answer like this questions will come. I hope this is clear, children. Okay, that's all. Okay, thank you for watching, children. And the next few problems, if you are interested, we'll just discuss in the next concept. Okay, thanks for watching. Have a nice day, children. Bye.